This is our lesson on rational functions and asymptotes. So before we jump in and start talking about asymptotes, we're going to review how to do the equation of a line. So this is something that we would have learned how to do in grade 9, practiced in grade 10, and then we probably didn't use it very much in grade 11, so our skills might be a little rusty. So our question here says, determine the equation of each of the following lines using the formula y equals mx plus b. So in the formula y equals mx plus b, the m stands for the slope and the b stands for the y-intercept. So there are multiple ways to find the equation of a line, but this is the one that we're going to practice today. So I'm going to take a look at my first graph, and I'm going to start with the y-intercept. That's the easiest place to start. So the y-axis is my vertical line here. Where it crosses the y-axis is my y-intercept. So the y-intercept here is 1. So my b, my y-intercept, equals 1. Now to get the slope, there's a couple of things you can do. You can pick 2 points and then calculate y2 minus y1 over x2 minus x1. We've used that this year when we were doing rate of change. Or when you have a line on a graph, you can actually try to count the slope out. So I want to try to find another point along this line that I can read the coordinates of. And if I follow my line, I think the next clean point, and when I say a clean point, I mean where it crosses the corner of some grid lines, would be there. So I went up 2 and over 1. And if I try it again and go up 2 and over 1, there I am again on the line. And then up 2 over 1, there we are again on our line, right? So the slope here, we're going up 2 and over 1. So my slope is delta y over delta x. You don't actually have to write that part. You really just need to write that we're going up 2, so 2, and then over 1, so over 1. Now 2 divided by 1 is just 2. So the equation of my line is going to be y equals mx plus b, or y equals m, so 2x plus b, which is 1. So the equation of this line is y equals 2x plus 1. We're going to try another one. So if I take a look at this line, first thing I want to do is find the y-intercept. So I'm going to look at the y-axis and find the point where it crosses, and that's at 5. Now, there will be graphs and questions where the y-intercept does not work out nicely. The reason we're doing equation of a line is to practice for oblique asymptotes so that we know how to graph them and find their equation, and the numbers for us will usually work out nicely. So we're not worried about ones where we've got decimals or fractions as my intercept, right? They should work out fairly nicely. All right, for my slope on this one, I'm going to start at this point and I'm going to try to find the next nice point. Now it looks to me here like I went down 1 over 1, but if I do it again, down 1 over 1, am I still on the line? What if I do it again, down 1 over 1? I am so not on that line. We're below the line. So that was not a good point. Next one is halfway through the line. I don't want that. Next one, partway through the line. I have a good feeling about this one. This one here would have been down 1, 2, 3 over 1, 2, 3, 4. So I'm going to check and see if that works to get to the next point. So I'm going to go down 1, 2, 3, 1, 2, 3, 4. Okay, so I feel good about that. And if I try doing it backwards, if I go 1, 2, 3, 1, 2, 3, 4, I'm on that line. So all of those helped me stay on the line. So we went down 3. So to show I went down 3 instead of up 3, I would use minus 3. And then we went over 4 to the right. So that's always plus 4 if you're going from left to right. So I've added 4 onto my x value. I've subtracted 3 from my y value to get to that point. So if I do delta y over delta x, I get negative 3 over 4. That does not divide nicely, so I'm just going to leave it as negative 3 over 4. And then my equation is going to be y equals m, negative 3 over 4, x, and then plus b, so plus 5. Okay, that's the end of our quick equation of a line review. You can join me in the next video to look at horizontal, vertical, and oblique asymptotes.